Hello, hello, good morning to all. Good morning. Due to network issues, I will not favor the, the video, but for those who want to see me, I know if it's active. Yeah, somewhere. Are you guys seeing me?
I can see you, sir.
Okay, okay. Like I said, I will not really favor the video because it will take a lot of data, and people may have difficulties with connection issues. Okay, in our first class, we try to look at some basic introduction into GIS. So we said that GIS is Geographic Information Systems. So today we are going to look at, try to define what is this GIS.
Bring pen and paper.
What is this GIS? What are the types of data and projection that we need to encounter, that we are going to encounter? What can we do with GIS? What can we do with GIS? What are the different types of data source and format? What are the different types of software that we use in GIS? And some little tips in data management. So, from our previous class, we defined GIS. So, can somebody define GIS? Can somebody define GIS? Can somebody define GIS? Are you guys getting me? Okay. Please, when you connect yourself, try to change your names. I'm seeing some names who are not names here. So Techno Power 2 is not a name. Try to change it to your name. Okay. So generally, GIS, which is Geographic Information System, is a framework for gathering, managing, and analyzing data. Are we there? So we consider GIS as a framework for gathering, managing, and analyzing data. So normally GIS is a science which comes from geography. Please, can you mute yourselves?
I never noticed.
The network is not all that good.
No, the problem is the net is some are making noise in the background.
Okay.
Yes, can you mute yourself, mute your microphones, mute your microphones. If you have a question, you type it in the WhatsApp group. I'll answer to you.
Okay, sir. No problem. Can we proceed?
Yes. Okay, I was saying that GIS, which is referred to Geographic Information System, is a framework for gathering, managing, and analyzing data. most of the time, this science is derived from geography. So, as we explained last class, GIS integrates many types of data. And most of the time, we are going to try to deal with spatial analysis that will try to incorporate data which are georeference that has a particular location, and those particular data again can be organized into different types of information, which we are going to look at layers, or visualize, which is maps. So the general characteristics of GIS are that this data can be in spatial. That is, it has a location. A good presentation of spatial data, for example, is if you want to locate the council of Boya, you notice that the council of Boya is found around Bongo Square, not far from Bongo Square, if I don't mistake myself. So you write council of Boya and you give it a particular coordinate, that is an X and Y coordinates. That will be spatial data. Now, tabular data, it is a representation of this spatial data in sheet format. So this format can be in Excel sheets or other types of tabular information. So how can we be able to produce such a data? First thing is to try to collect the data. When collecting the data, you may use a GPS and so on, or any other mean. When you extract it in the format that you want it to be displayed. Most of the time, this format is displayed in Excel format, that is in tabular form, which gives us directly a tabular form. But there are other formats. You have KML format, KMZ format, or shape format, which are spatial format, that is data. That's not tabular form. So after that, you need now to organize the data into a meaningful way. So after you have input data into particularly maybe in the software, collect the data, input it in your machine, you need now to organize data. You can collect data about the location of different houses or different companies that you may wish to have ties with them, or maybe they may request your different services. After collecting the data on those guys, you need now to structure them. What are their activities? What may be are their interests, and so on and so forth. So structure them in the data, that will be data management. Now, after that, you analyze the data. Analyzing the data is to try to answer to a particular question. And that question needs to be extremely explicit. A good example is, I wish to have the representation of the population of Moiko in the Southwest. So in spatial form, that will be density of the population of Moiko in Boya. That will be the density. So now, you as a transport logistic manager or other, now what does this data, what can you do with such a data? Just imagine that when you collect, you were able to collect data on the different companies or structures or firms that are in Moiko, and now you have now the different population of Moiko, and another data that you can have is the checkout of the product that they sell in Moiko. Now you may find now a link between the population and a specific type of product. Now, question to do analysis. What's the correlation between, for example, just take a phone, a company which is doing selling of phones, and want now to you want to try to look at the correlation between the number of people buying a particular phone, or by which are buying in which type of shops are selling the more phone in Moiko. Now you have data, you give it from a density values that you display in a map, you have the answer. But now the answer that we will give it to you may help you now to understand that this particular shop is selling more than the other one because it is having a higher density than the other. Okay, after doing this analysis, you will now generally produce a map in there using their different layouts, and you need to respect their international format and standard. All of this now is done using different softwares and hardwares that we know. So we were speaking about layers. What is a layer? When you're looking at layers, yeah, layer most of the time represent spatial data that has been digitized in. So a good from your screen, you have a representation of a polygon. This polygon represents a boundary of a locality that you can observe. So, are you seeing my mouse?
Yes, sir.
Okay, so from the mouse, you will see that these boundaries are dividing the different localities, and each of them have different colors. So most of the time, we use polygons in maps or in as a special data to give localities, or to give the geographic location or geographic boundary between different localities. It can be a council, a municipal council, it can be a country, a quarter, a village, and so on and so forth. Now, in our last class, I said that you also have another type of layer, which is point. Point. We have another type of layer, which is point and lines. So, lines, most of the time in GIS, it is representing road network. It is representing road network. In case in this our case, we're going to observe that these lines are representing a road network that enables to connect that's problem of network. Anyway, let us continue. So these lines generate a road network that enables to connect one city or one country or one locality with another. And most of the time it's represented into red, yellow, and black color. Now, in case you have lines which are in blue, it means that it gives us an idea of the streams, river network, and other things related to water. So when you have a line which is blue, it's representing water. If you have a line which is green, it is representing a watery environment. It may be a stream or a contaminated river, and so on and so forth. But in standard, most of the time, road network are the red, yellow, and black. So now, the points here may now represent the different junctions that are found in the road network. A good example is if we want to leave my 16 to reach Biaka, we are going to stop at, we are going to meet the first junction, which is my 17. We have a small junction at my 17. The next junction that we are going to meet will be Malingo. The next junction that we are going to meet will be Checkpoint. And lastly, we are going to enter through a small junction, which is Biaka Junction. So those points can represent different types of information in GIS. So, but in road networks, most of the time, it represents junctions, it represents the different structures. You can give names to a particular locality, and so on and so forth. So, from the background of the shapefile, we notice that this is a shapefile. Here is a shapefile which incorporates polygons, lines, and points. That is spatial data. And now, in the background, we have raster images, which are represented in pixel format. We have raster images that will give an idea of the representation of that particular locality. Here, the resolution is very, very poor, so we cannot clearly observe what is found in each of these locality. So, what are the different types of spatial data that we have been discussing about? We said that we have two types of spatial data. We have vector, which is in points, lines, and polygon. And we have rasters, which are most of the time are in pixels, which are made up of rows and columns that are most of the time represented as matrices. So just take a good example. This may be what or the earth or a particular environment. Just imagine that this is Dongo water, and that this Dongo water we have is connecting different points in where it will be represented spatially as raster data, as what you observe here. And in vector form, we're going to have a polygon that will represent the lake. We're going to have a blue line that will represent the different streams. We're going to have the brownish that will represent the land. You have the yellow that will represent the marshy areas. That's the areas which are watery. And we have the green that will represent the forest. This green will be a polygon. The yellow will be a polygon. The blue line that will represent the stream will be a line. The blue inside will represent the lake, will be a polygon. And the others, that's the land, which is a grassland, will also be a polygon. Now, this point, grassland, is a point. The marsh is a point. The forest is a point. And the lake is a point. When we will be looking at practicals, we are going to look at how can we display such information in vector format. So, like I said, most of the time vectors, which are in polygon points and lines, are represented as such. So these red dots are points, while the light green are the polygons, which represent the boundaries. While the points may represent any type of information, it may be a location of a particular structure or a particular event or environment. While the lines here most of the time is the stream and the road network, as represent waterway network or road network. So that was more of vectors. Now, when we look at raster data try to represent the real Earth in a particular model. So it's trying to represent the Earth in a a more realistic way as it can. But all of this representation, most of the time, is in a particular specific arrangement that is follow a regular grid of cells, which is made up of rows and columns. All of these now, most of the time, are these cells. All of these cells are most of the time are considered as pixels. So now, each of these cells has a particular value. These cells range generally from 0 to 256. That will be the different ranges of colors that you guys know. Now, the combination of these different colors in the pixel give a representation of this particular image that you can observe here. So, from this raster image, we can have now this type of information. So, from this agglomeration of pixels, you can have these different types of information. This too, if you follow here from your left, you see a Google Earth image of an area. That's satellite image of an area. Here you have an elevation model still obtained from the raster data. That is from SRTM. That's elevation data that has been produced the model obtained or extracted from satellite imagery. And now we have a scan map. Of an area here to your right, which gives us a global information of geographic information on the area. Now, next is we said first that we need to understand the data. What is the data? How do we input the data? To be able to input the data, you need to understand what the background of that particular data, what is behind the spatial data. If you want to go and collect data, you need to know what you want to collect. Why do you want to collect that data, and what is the use of collecting that particular data? So, you will not just go to the field and collect data haphazardly. So, to be able to organize this, you need to understand what is data attribute or attribute table. So generally, special data have a back-end database called attribute table. This attribute table are the characteristics of the data itself. A good example is if you want to go and collect data about the different stores found in Moiko, the first row that you will need to, in your data sheet, in your Excel sheet, you need to have a column where you have name of the store, activity of the store, after activity of the store, you may now put the income or the income generated by the store and number of people served by that particular store. So that will be the data that you want to go and collect. This data, you put it in your Excel and now insert maybe it in your GPS to go and do the collection of those particular data. When you collect the data, you give you those information that you collected on the name of these different type of stores, the name of stores, the activity that are carried out, the income that is generated, and number of people that they serve. Now, this will permit you, when doing your analysis, to maybe request a particular shop, a particular shop found in a particular locality, each information that you want to do. let me try to represent it in an Excel sheet so you guys can understand what I'm saying. Give me some seconds. Let me put on the Excel sheet.
Okay.
Okay, are you guys seeing my Excel sheet?
Yes, sir.
Okay, so if okay, this would be name of the store. I want to collect data in Moiko, so I need name of the store, the activity is carrying, as the store is doing. Now, number of people
Okay.
it serve. Output, the income that you generate, and order, and others. So you can increase what you want to do. So now let me take, for example, Manchester. Manchester activity is phone and accessory. Number of people that you may serve per day, maybe let us say 30, and the income, let us say 200,000 francs per day. Okay, so naturally, this data are going to have X and Y, maybe Z. Right? So you may have Z. So here will be flat, long, and altitude. Okay, so for the others, you can have now store A, store B, and continue with the different type of stores, store B, C, and so on and so forth. So now, with this data that we have here, if now we want to do an analysis on, for example, when I was saying density analysis, I'm referring to the population here. You have maybe the population data of people already in Moiko. And now, from this population data, number of people served per store, you will know the number of people. You will now try to correlate the number of people served by this store by the number of people, maybe the number of houses found in that locality. Is there a link? If yes, now, maybe now you can go and do another survey on the local people living around that store. Are they made up of youths? Are they made up of adults? Or, so you now understand the tendency of them. Maybe they want, that's why they want more phones or accessories related to phones. That will give you an idea of why is it Manchester, for example, why did he choose to situate himself in that particular locality. So now, you as the logistic man, you will now understand that, okay, this store, he makes an outcome of this and this. He sells out this number of phones per day. Maybe it means that each week he moves to Douala to go and buy phones and come to Boya. So maybe now I can go to him and offer him my logistic services, that I will be in charge of carrying his phones from Douala to Boya. He doesn't need again to travel. You just need to put me into contact with the person who is selling the phone or retailing him the phones that he buys in Douala. Are we there?
Yes, sir.
Okay. So this is another good representation of attributes. You see, yeah, we
Hello?
are using ArcGIS. Yes, hello. People are coming in, going out.
Yes, sir, I have a question.
Yes,
Yes, sir, I have a question.
ask.
So, what's the relevance of this study what's the relevance of this study to a supply chain manager?
We'll come to it at the end of the class of the lesson of today. I discussed with it in your colleagues last time. We'll come to it. Bro, are we there?
Okay, sir.
Okay, be
Yes,
Okay,
sir.
patient.
thank you.
Be patient. You understand calmly. Be patient. Okay, let
Okay,
us
sir.
just look at this different representation. This America, naturally. We have Massachusetts, New Hampshire, Vernon, Maine, Connecticut. I know all of you guys should know already the name, these different names, due to the election that happened recently. So, actually, they already have a database. They know the number of total population found in each of these different localities. So that is why they may know the number of people that can vote, and the number of people that can vote in those particular locality. So this is the attributes that was talking about. We have the polygons here. The polygons here, which have the different different numbers given to them. We have their acronyms here. I have the names of the polygons and the population found in the different polygons, like the number of people living in these different localities. So this is another good representation here. Yes, a map.
Hello, sir.
Yes.
Hello. Yes, sir. I wish to know what are polygons.
Explain it.
Sir, I'm sorry. I just joined the class.
Yeah, you watch the video. It's recorded. Are you hearing me?
Yes, I'm getting you.
Yes, you watch the video. You watch the video.
Yes, sir, I'm getting you, sir.
Okay. I'll send the video at the end of the class in the group.
Okay, sir.
Yes.
Okay, sir.
So this population density, this population here in this map, give you an idea of people living in that particular area. This now, what will this population mean to you? You as a person. You know, the higher number of people living in an area, the higher number of services they need. A good example is people in Douala. The transit between Douala and Boya is higher compared to the transit between Douala and Kumba, because the number of people living in Douala is higher compared to the number of people living in Boya, and the number of people in Boya is higher compared to the number of people living in Kumba, knowing the situation in which we are actually. So the movement of activities between Douala and Boya will be higher compared to Douala Kumba. Similarly, the movement between Douala Limbe will be higher compared to Douala Boya, because naturally Limbe is a touristic site and has other structures and company that makes them to be more accessible to that make them to more attractive compared to Boya. So if you want to build maybe a logistic company, you need to take these different population density into consideration and the transit activities that are happening between them. Please try to come online back. We are going to